In this lesson, I'm going to give a brief overview of the initial project file, set up a few aliases, and start setting up our first simulation. So the first thing we're going to do is just go up here and close our shelf tools, give me a little bit more real estate. So when you first open the project file, you'll notice these three objects right here. We have our launcher geo, which we're going to use to birth our particle simulation later. The ground geo, which is just a grid colored green. And our rocket geo, turn these off, which is just a simple tube that I did a few operations on to shape into a rocket. For the purposes of this project, these geometry objects will suffice, but if you want to use your own rocket or your own rocket launcher for this project, please feel free to do so. But for the purposes of this effect, these will work just fine. Turn those back on. So, first thing we're going to want to do is set up a couple variables to link to our directory structure that we're using for this project. So you see in my root Houdini rocket swarm directory, I have these three directories. We have our HIP directory, that's where I'm putting our project files, data directory, which is where we're going to write out our data, and a PIX directory with an out directory for our image sequences, an AVI directory to take those image sequences and turn them into AVIs or MOVs or whatever works best for you. So we are going to be doing several file out operations during these lessons. Rather than having to type out this whole C, Houdini, rocket swarm, PIX, out directory over and over again, instead I'm going to make some variables to reference that directory structure so we can just use those variables instead. So I'm going to go up here to aliases and variables. And under variables, I'm going to start off by making a data variable, which is going to link to C, Houdini, rocket swarm, which is our root directory, data. And I'm going to do the same for PIX. Go ahead and copy paste that string. So for PIX, we do, instead of data, do PIX out. So when we do our file operations later, rather than typing this whole string out, I can just do $PIX and then we'll get that string. So now that we've got that set up, let's start setting up our first simulation. The first sim I'm going to want to set up is probably the fire that comes off the edge of this rocket. So I'm going to go ahead and drop down a new geometry object. And I'm going to call this rocket fire emitter. And let's dive inside of that. Let's go ahead and delete this file swap. And we're going to put down the sphere. And let's go ahead and make the sphere a little bit smaller. I'm going to go ahead and just do a copy parameter, paste copy relative reference, so that if I need to change this later, I can just change this one channel, update all the other ones. For now, 0.5 should be fine. I'm going to put down a points from volume SOP to get some points that fills in this entire area of the sphere, as you can see here. Now this is preferable to using a scatter SOP. For scatter, we're going to get points just on the surface of the sphere and not inside the sphere. And for the purposes of creating our emitter volume, we're going to want points inside the sphere. So this should probably work fine. Now this is pretty uniform, so I'm going to go ahead and drop down a VOP SOP. Hopefully you've done VOP workflow before, so this should be pretty familiar. And I'm going to use this VOP SOP to do some noise on these points. So I'm going to go in here, and let's do a curl noise operation. So I'm going to do curl noise VOP, and I'm going to use the position of our points to drive our curl noise. And we're going to want to add this resulting curl noise to the position of our points. So put that into the first input, the noise into the second input, and we're going to want to output this to the point position. As you see here, now we have our points all nice and noised up. Now these are a little bit too much noise. Let's bring down the amplitude to something like 0.18. And that should probably work. We just want a little bit of noise, not too high frequency, so it's a little bit more broken up. So now we have that. Let's go ahead and set up our fluid emitter. We're going to drop down a fluid source SOP, which wraps up all the fluid source operations all nice and tidy into one SOP. Now we are doing our source off of points, so rather than method build SDF from geometry, we're going to want to stamp points. And as you can see here, now we have some volume here. Now we are going to be doing a pyro simulation based off of fuel, so rather than creating a density field here, we're going to want to come over to the container settings, and rather than source smoke, we're going to want the source fuel. This is going to give us the correct fields to do our pyro simulation. Now this is a little bit blobby right now, so we're going to want to break this shape up a bit. To do that, we're going to come over to the scalar volume noise, which should already be turned on, and we're going to add to this noise to make it a little bit more crunchy. So let's go ahead and change the sharpness to 1. It's going to give us a little bit more defined edge. Now let's change the grain to 10. And now you can see we have a little bit more breakup, a lot more visible breakup in our noise. The reason we want this is so that when our fire is birthing, these areas of negative space are going to make our flame look more interesting. We're going to have more flame here, less flame here, and it's going to help break it up more. So this is about all we really need for our fluid emitter. I'm going to go ahead, just drop down a null, call it out, so we can grab that easily. And then one other thing I'm going to do is I'm going to drop down a bound SOP. I'm going to call this bound. And this is just going to build a box around our emitter. And this will be useful later for setting up our bounds in our sim. So that's how we get our aliases for our data setup, and we set up our initial emitter. In our next lesson, we're going to continue setting up our simulation and actually do the pyro simulation for the rocket fire.